Well, Kari, thanks very much for sparing us some time here at SNEC. This is a new tool that Manz is introducing, but more importantly perhaps it's a new sector for the company to approach. Can you give us a little idea of what it's about?
Yes, sure. Manz is now closing the gap in the production steps of manufacturing silicon wafers, and we have all the back-end line in the back, and now we are still missing like the wet chemistry tools, and that's why I'm now working for Manz, and I'm the product manager, and I'm responsible for the portfolio of the wet chemistry tools at Manz.
Now, as a wet chemical process, what are the key features of this tool?
The key features of this new IPSG CEI 4800 tool is, of course, the edge isolation and the phosphor glass removal.
Now, what are the challenges at the moment then that people have with this type of process? Because it's a standard kind of process for everyone.
It's a standard kind of process, but the problem is the customers, they want to have a financial benefit, and so what you have to do is to have a higher throughput and for a less price, and this is a big challenge, of course, and that's why we're going up to 4,800 wafers an hour, while our competitors only have like 3,600 wafers per hour.
But there's always been a challenge with high throughput in a wet chemical process because of the variability. You know, the faster you go, the poorer the actual process is. So what's some of the features then that
it's a challenge why we're using some different kind of rollers. We're using the sponge rollers, and this technology that we have developed is that it's very soft and tender, and we can go very high speed on the belt speed. So we're running here at the moment a belt speed about from 2.5, 2.6 meters per minute, while the competitors only run like 2 meters, 2.1 meter. And that was a challenge, of course, to have the process very stable, because we have to have a more stable process to convince the customer to buy this machine.
So if the process isn't stable, what are some of the challenges people face? What are what do we see in the process then when things aren't stable?
What happens at the normal, like in competitors, when the biggest issue is the edge isolation, because you only have the back side of the wafer to etch away. And this is very difficult, because usually when you go high belt speeds and the wafer is swimming on the etchant, you have the problem that you have over etchant on the sunny side of the wafer. And so this is very difficult. And once you have over etching, you have of course less efficiency on the top side of the wafer, because parts of the wafer, of the emitter, is not good anymore.
Now, another new aspect to this particular tool is that it's not actually being made in Germany. This is actually a tool that's going to be made in China. Give me a little bit of understanding why you're doing that.
That is right. Because what we are saying here, now it's engineered by Germans. That is really like a funny wording game, but it really makes the point. We develop in Germany, but we're going to build it here in China. And last night we inaugurated the new fab in Suzhou, which has over 15,000 square meters of production site. And it's important to get this price for this tool. We can only make it in China, because the prices are much better here to produce, and also here's the market. So why should we produce in Europe if there's no market at all? We have to ship it for expensive money, and we have it here. Here's the market, here we're going to build.
So for the evaluation side of this, that's also the advantage, that you've got the tools being made here, that people can do the evaluation work here.
Right. Many more customers start now, when they're in the procurement department, they say, if we want to buy new tools, look for tools that are made in China. They're cheaper. And we compete with this tool, we compete with any price here in the Chinese market.